Okay, in this lecture, we're going to be going over binomial probability distributions. Binomial really means that there's really only two possible options. It's either a success or a failure, a heads or a tails. There's only two possible options. So that's really important to remember with binomial probability distributions. Okay, so let's take a look at this. You're going to be able to compute the mean, variance, and standard deviation of the binomial probability distribution. You're also going to be able to explain the assumptions of the binomial distribution and apply it to calculate probabilities. Okay, so what's really important is before you ever attempt to do a binomial probability distribution, you need to make sure that the data that you're working with meets all of the assumptions. All of the assumptions. Okay? First, an outcome on each trial of an experiment is classified into one of two mutually exclusive categories, a success or a failure. Or, for instance, when we were working with the dice, above three, equal to or less than three, or equal to or greater than four, that would work because it's a binomial probability. It's either above equal to or above 4 or equal to or less than 3. There's only two options, and they're mutually exclusive. A random variable is the number of successes in a fixed number of trials. In other words, you have a fixed number of trials, and there's a random variable that determines the number of successes. Okay, and we'll get into that in just a minute. The probability of success is the same for each trial. Okay, that's not to say that everyone has to be 0.5, but everyone has to be the same. So if the probability of success for the first trial is 0.2, then the probability of success for the second trial needs to be 0.2. For the third trial needs to be 0.2, and so on. All of them have to be 0.2, or all of them have to be 0.3. But the probability of success has to be the same for each trial. And then the trials are independent, meaning that the outcome of one does not affect the outcome of the other trial. Okay? So those are the rules, if you will. So right here we've got the formula. So this is saying the probability of x equals the combination of, and then n is the number of trials, x is the random variable, saying as the number of successes. Okay, and then here is pi raised to the x. Now, when you see pi, we're not talking about 3.14. Pi stands for the probability of success of each trial. So if the probability of success is 0.2, then you put 0.2 raised to the number of successes. The random variable defined as the number of successes. Okay, and then in parentheses, you multiply that by 1 minus the probability of success for each trial, and then you raise that up to the n minus x, which is the number of trials, minus the number of what's defined as the number of successes. Okay, so let's do something that I know is all near and dear to y'all's hearts. We want to know what is the probability that the Baylor Bears will have a winning season, given what we know already. First of all, given what we know already, they have a total of 3 wins, and they have 2 losses. Okay. And they have 7 remaining games. Okay, so we want to know what is the probability that they will. Well, let's look first at the probability of them just having a 500 season. Okay, a 500 season, exactly a 500 season. So we look at 7 games is what they have left. In order to have a 500 season, they need to win at least 3 of those. Let me put this in a different location. Okay, they have 7 games remaining, so n, and then 3 is x. Okay, so remember how to do the combination formula. That's the first thing that you have to do. You have to do the factorial of 7, so equals fact 7 divided by let's see, fact 3 multiplied by 7 minus 3, which is 4, fact 4 and so that right there is the combination formula. So factorial of 7 divided by factorial of 3 multiplied by the factorial of 4 in the denominator. So that gives you 35. So that's a combination. So now we have pi. What is the probability of them winning a given game? The probability is 0.5 is the probability. So 0.5 equals 0.5 raised to 3 multiplied by, let's put these in parentheses. .5 raised to 3 multiplied by 1 minus pi, or 0.5, because 1 minus 0.5 equals 0.5, times 0.5 raised to the n minus x. N minus x is 4. And that's 0.07813. So then we have equals 35 multiplied by 0.07813. So the probability of them having a 500 season exactly is 0.273438. Okay. So let's take a look at something a little bit different though. Okay, so what I just did while I paused the video is I put right here the number of successes, or x, and then the number of remaining games. Okay, so the probability that the Bears will win 0 of their remaining games is 0.07813. Now, when I say 0, I mean exactly 0. Okay, the probability that the Bears will win exactly 1 of their remaining games is 0.054688. The probability that they will win exactly 2 of their remaining games is 0.164063. All right, now what if I want to know what is the probability of them having a winning season? What is the probability of them having a winning season? In order to determine that probability, we need to add up all of the probabilities of 4 or higher, because if they win 4 games, then they will have a winning season. So 4 or more games, they will have a winning season. So equals sum 4 or higher. So based on this, the probability of them having a winning season is 0.5. Okay, because I added up all of the possible outcomes, or all the possible occurrences of them having a all the possible outcomes that would result in them having a winning season. Okay, so what is the probability that they will have a losing season? So equals sum, and we add all of the possible outcomes that would result in them having a losing season, which would be 0.226563 would be that probability. Okay. Here they give you an example of flights. If you'd like to, you can work through that on your own. And they do the same thing here. Now, with the binomial probability distribution, you can calculate the mean and the standard deviation and the variance in the same way that we did before by calculating. Here, I'll just do it really quick. So the probability of x, so right here, you've got x, and then you've got the probability of x, okay, and then equals x multiplied by the probability of x. Bring that down. Okay, so then equals sum, okay, which is 3.5 is the mean. Okay, so then you take x, so equals, whoops, equals minus the mean, and you bring it down, and then you square it, equals and then after you square it, you multiply it by the probability again, multiplied by probability, and then you sum all the probabilities, or sorry, sum all of these results or products, if you will. And so the variance is equal to 1.75, and then equals square root. The standard deviation of this distribution is 1.322876. Okay, so, and then variance. Okay. However, there is a simpler way to do this. And this is what can be referred to as a shortcut formula, if you will. 7, because you've got 1 through 7, multiplied by 0.5, okay, which is 3.5. And you notice 3.5, 3.5. And the reason why this works is because it's binomial. It's either success or no success. And then for the variance, we do n, or equals 7 multiplied by 0.5 multiplied by 1 minus the probability of success, which is also 0.5, which gives you 1.75. Okay, so that's the shortcut for a binomial distribution. It does not work unless there are only two options. It needs to be either classified as success or failure. So don't try to do it if you're looking at 4 different options, or 10 different discrete options. So there has to be 2. Okay. And then I also want to introduce something to you called the binomial probability table. This is really if you have you see n6 for when you have an n of 6 and you have an x of 0, 1, 2, 3, 4, 5, or 6, and a probability of success of 0.5, 0.1, 0.2. So if I have 6 possible events, and I consider 0 to be a success, and the probability of the success occurring is 0.05. The probability of it of x occurring 0 times is 0.735. The probability of if the probability was 0.1, the probability of x occurring 1 time or 0 times would be 0.531. The probability of x occurring 1 time would be 0.354. The probability of x occurring 2 times would be 0.098. So you can see right here is the probability of the success. This right here is the designated number deemed as the number of successes. And so you can use this without doing all the calculations if you just have the numbers. And there's a lot more, obviously this right here, this is the binomial just for n equals 6. You would need one for n equals 5. You would need one for n equals 7. And for that reason, this particular binomial probability table isn't as useful as some of the other probability tables. And that's why I really won't be giving these to you. And you really just need to learn how to calculate the binomial probability distribution, or learn how to use software to generate it. There's also this right here, the cumulative binomial probability distribution. This is what I was talking about earlier with adding these up. So if you want to, you can look through here to really see what they're talking about with the cumulative probability distribution. So that's pretty much it on the binomial probability distribution. This is going to take a little bit of time for you to work through and practice with. It is extremely useful, so I'd definitely encourage you to get as much practice as you can with this.